It's Kamal and you're watching Maths by Jajoria. Please don't forget to subscribe my channel. In this video, I will also explain functions and continuation from my last video where I explained a function thoroughly. So this example would be just a continuation of that. I will also discuss a quadratic graph in terms of parabola. Okay, so just a continuation of previous video, the function, one of the example I would like to discuss as well. So the function f is defined as this equation, which is on the screen. Okay, fx equal to 3 power to 2x minus 28, and that's in bracket 3 power x plus 27. Okay, where x is the member of real numbers. Okay, and I also explained to you last time that what this means. Okay, so please watch that video as well. Now write fx, which is this equation, in the form. So what the examiner will ask, write in some form. So here the form has been given to you. Okay, this is where a and b are real constants. Okay, now okay, so the first step towards that, let's write down this equation. So what is fx? Is 3 to the power 2x minus 28, then 3 to the power x is in the bracket plus 27. Okay, so that is your fx. Now you know you can write this as okay. So what I've done here is just simply have written this. So this can be written like this. Okay, right. Now to solve this equation, what you need to do, you need to let, say, 3 to the power x is equal to x. So just let's presume that. Okay, so that you can simplify this in the form of like quadratic equations. So you see, if you do this, what this can be written as x square minus 28 x plus 27. Okay, so now this is pretty simple for you to solve. So factorize this. In order to factorize, so that will be the product. Okay, then sum or add, whichever we want to say, same number, that will give you minus 28. Okay, so let's bring this over here. As you know, 1 can be written as like 1x, or you can just write x. So it's minus x and plus 27. Okay, clear so far? And then okay, so you got this simplified. So you got x minus 27, and also you got x minus 1, right? Now, because the examiner has asked the write fx in the form, so this form we need to write. Okay. Now, if you leave this here, that's not really completed answer. Because you had up here, you said let 3 to the power x is equal to the x. Okay, so you have to put this back into this equation. So now you write substitute 3 to the power x into x. So you have to put back into it. Okay, so what you will get then? You will get okay, so you got the form which has been asked you here. Okay, so it's exactly the same form. Okay, so you can be asked to solve some of the functions in the exam like this as well. Okay, hope is clear. Now I'm going to move on to quadratic graphs. Obviously, it's just a continuation from the function and then moved on to the quadratic graph. Now, I have discussed the quadratic graph previously as well, but in that examples, we were actually inserting or keying in the values of x and then getting the values of the y. Therefore, we were getting the coordinates. And then according to the coordinates, xy coordinates, we were drawing a quadratic graph. However, here is a bit different. Okay, so I explained to you. So let's say you have a equation which is a function of x is ax squared plus bx plus c. Okay, so this is most of the time we talk about this equation in this form. So this is your fx, and it says the graph. Then you have to draw the graph basically. If you have, when you have this fx equation is this kind of quadratic equation, and it says the graph y fx has curved shape called a parabola. Okay, so when you have been given this and you have a curved shape, which you know the most of the quadratic graph, you get curved shape like a U. So in this form, you see this here, whether up or other side, up or up down. So either this way or this way. Okay. So we will explain this. I will explain you this as we go through the example. So again, when you have fx with this equation, quadratic equation, the graph of this equation that has a curve, and that shape would call parabola. Okay. Now you can sketch a quadratic graph by identify key features. Okay. So what new in this one is that we need to identify the quadratic graph by identifying the key features, and the key features I will explain to you step by step, which is here as we go through the example. Okay, and in that key feature, the coefficient of x squared determine the overall shape of the graph. Okay, so you will see that as well step by step when we do. Now before we start anything, when a is a positive, the parabola will have this shape, and when a is negative, the parabola will have this shape. Basically it's just the other way around. It's like a cup. You put one time straight and then one time other way around. Okay, ups and down. Now what is a here? A here is a coefficient. Okay, so this is what it's saying, that if the coefficient here a is positive, then you will have this shape. If A here is negative, then you will have this shape. Clear? So let's talk about example so that the things can be clear to you. Right? So the example is, it says sketch the graph. Okay, so let's write down here. Sketch the graph of y equal to x squared minus 5x plus 4. Okay, so this is what has been given to you. And what it's saying, it says, and find the coordinates of its turning point. Okay, so this is what we have to achieve. Right? Okay. So what's the first bit here? Now, here it says when A is positive, the parabola will have this shape. Okay, so it will have like a U shape. Yeah. So what we have here, A, as you know, this is A here. Okay, so there's positive here. Yeah, there's no A, but you can say that the A is 1 here. As A is 1, okay, and it is positive, what the graph will have? Graph will have this shape. Okay, and the minimum point. Okay, so you'll have this shape and the minimum point. Okay, so how we'll get this? So you see here, it says the first step, it says the graph crosses the y-axis when x is equal to 0. The y coordinates is equal to c. So here the y crosses, so here the graph crosses the y-axis here. Okay, that's why I got here 1 as well, as it's 1 first. You can see this here. Yeah, let me just, so this is here. The graph crosses the y-axis when x is equal to 0. So what we will do basically, we'll put this equation is equal to 0, and then you will get y coordinates which is equal to c as well. So that is your c. According to this equation, this is your c, so that is your c, and that's why you are here. And if you have this parabola and this is your graph crosses the y-axis. Okay, so that's why I got here 1. The first key is this graph crosses the y-axis when x is equal to 0, and that's what you got here. Right? Okay. Now let's do it by example as well. So when x equal to 0, yeah, then the y will equal to 4. So the graph crosses the y-axis, and these are the coordinates at 0 and 4. Okay, that clear? Okay, So now, obviously, you want to see that as well. How did we get that? Okay, so let's do this for you as well. So all you did, you have this equation here. Okay. Yeah. So inserting x equal to 0, x equal to 0, so that's 0, that's 0, you go just left with 4. Okay, so the y, that's where you got y equal to 4. Okay, so that's 0, and you got y equal to 4. Okay, so I'm pretty sure you can do this yourself. Right. Now, the second key here, that graph crosses the y-axis. Now it's y-axis, yeah? When the graph crosses the x-axis when y is equal to 0. So what do we have to do now? Here, in this equation, now we will say y equal to 0, and then try to get your x coordinate. And this is where it says the x coordinates are the roots of the function fx. Okay, so this is here, I donated by this by 2, and you see you got here and here, and these are 2. Okay, right, like here, that's 2, that's here 2, that's here 2, and here as well, that's here 2. You got it? So these are the points here. When you get this, when you have y equal to 0. Okay, so we have to do this as well. So when y equal to 0, okay, so let's do this. So you say when y equal to 0, that's your equation. This is what you will get. Okay, so now this is the example. Okay, so in this example, this is the example of factorization. So these example factorize, but you may need to use the quadratic formula or complete the square. So whichever you want to use. So the quadratic formula or the completing the square, if you are not sure how to do that, you can always watch my previous videos. I have explained that quite in details about these. Okay, now I will explain to you here so that some of the students, if not sure about this, so let's do this, factorize this with one of the example. So same thing, you need to get the product where you can get 4, and then you add or multiply whatever you do, then you should get -5. Okay, so that you can achieve by, if you have a number -1 and -4, that will give you 4, and then when you add these two number minus number, that will give you -5. Okay, so let's quickly do these things. Okay, so that is your x square minus x minus 4x plus 4 equal to 0. Okay, let's simplify this. And this is what you got. So you got x minus 4, and then you got x minus 1, in bracket, and that is equal to 0. And this is where you got then x minus 4 equal to 0, and x minus 1 equal to 0. So x is your 4 and 1. Okay, so this is what you got 2. So what would be your 2 coordinates? That will be your 1 and 0, because y is your 0. This is what we have here. And you got 4 and 0. Okay, or you can say 4 and 0, 1 and 0, whichever you want to say. All right. So let's draw this on. So let's see this as well. You got coordinates now, so we can draw that as well. You got this here, you got also this coordinates. Okay. So let's say if I do this, I'm sure I can really do here. Okay. Okay. So this is how you will do in exam. Okay. So the examiner will ask you to do in this method. Okay. Not by inserting the values in there. Okay. So this is how you have to achieve your shape. So this is how you will do. So okay. So this is your x and this is your y, and that's your 0. Okay. So the first one was here 0 and 4. So you got 0. Let's say you can say 1, 2, 3, 4 here. So you see here it says that the graph crosses the y-axis at 0, 4. So it will be crosses like this. Okay. So this is your 0 and 4, right? Then you also got 1 and 0. So you got 1, 2, 3, 4. You can say like this. Okay. Okay. So let's say, sorry, ignore this, please. Let me have a pencil. Not much easier for you. So this is your 1 and 0. Then you got here 4 and 0. Okay. So you see you'll have, so let's presume this is 1 and this is your 4. Okay. So please ignore this. Otherwise it will be difficult for us to draw graph. Okay. Okay. We still have to get your minimum point as well. So we will talk about that as well. Okay. So that point as well I will explain to you. So this is so far you got x here and you got here y-axis and at 2 points at the x-axis. Okay, that's clear. Now we have to talk about this area. Okay, because it says here, okay, we done this one. Then it says quadratic graph have a one turning point. This can be minimum or maximum. Okay, so this can be like here minimum or it can be maximum. Okay, since a parabola is a symmetrical, the turning point and the line of symmetry are halfway between the two roots. Okay, so halfway between the two roots means, so these are the two roots. Okay, so this is halfway we're talking about. This is what we halfway we're talking about. Okay, so here you halfway. Okay, and also here you can say halfway between the 2 points. Okay, here and you can say here. So here halfway. Okay, the same thing would be here. These 2 points. Yeah, these 2 points here. Okay, and then it will be like halfway. So these we're talking about here, these 2 points and the halfway. So the points would be here. Yeah, so halfway. So like you can just go through there. So you will see probably it will be here, but obviously we have to get that coordinate. Okay, and we will do that as well now. Okay, now before I explain that, some of you probably have watched my previous video, and I have explained in details completing the square. So the quadratic graph of completing the square. Okay, so if you haven't, then please watch that video. So you can find the coordinates of the turning point of the quadratic graph by completing the square. So it's just one of the method which I have explained in details. Okay, and that gives you turning point, okay, in the turning point at minus P and Q, where you have fx as here, okay, and this is the graph of yx as a turning point. So again, if you're not sure, please watch my previous video. Okay, I will also have the link as well in the description box. All right, for this video. Right, so let's move on. Let's get that. Okay, so what you have here, you have here, okay, this equation, x squared minus 5x plus 4. So now we solve this by completing the square. By completing the square, okay. So the formula would be, this is what I have discussed in previous video. So if you have, this is how we achieve this by completing the square. Okay, I write down for you. So I still write down for you. Right. So we have to get in this form. Okay. Right. So let's add this one here. There's not enough space. Right. Otherwise it will be difficult for me. Right. Okay. Like this. So from here and using this formula, what we will get? Okay, clear? So let's go here. So if you have here x, then b is your 5 here, and then you have to half, and that you got here half, because this is minus, you will get this minus here. Then you write minus from that, and b, you half that. Okay, your b, half that b, so your b here is 5 again, so you half that, and then you square of that. Okay, and then you already have plus 4 here, so I have written plus 4 here. Right, as I said, if you're not sure, then please watch my previous video. Okay, so by simplifying this is what we get. Okay, so you just simplify this. So ignore this. So this is what you will get now. Okay, so when you simplify it, you get this. Okay, so now the the coordinates for your, can you see this? Yeah, okay, so coordinates for this here, the minimum, that will be your this and this here, because it says here, okay, it says when the equation is like this, which is completing the square, this is our equation, the graph of yx has a turning point of minus p and q, which is this is your p, yeah, minus p, and then this is your q. Okay, this is what it says. So this is your same as this here. Okay, so we got achieve this by completing the square, and then when we're completing the square, this is the coordinates we got. So what would that would be? That will be your pi by 2 and minus 9 over 4 or 9 over 4. This is your coordinates, okay? And this coordinates, then we will have this here, okay? So you will see somewhere here, you will get this, okay? Your coordinates, so that will be your minimum point, okay? So hope it's clear to you. Now, do me a favor, as I say always, if you find this video informative, please like and subscribe this video. Okay, and be sure to click the like button and drop a comments if you have any questions, and I will do my best to reply. Okay, thank you.